So here we have a longitudinal wave, where the force and energy move in the same direction. But let's break it down. So here we have the crest, the trough, the amplitude, the wavelength, and the rest. Energy and the force moving in the same direction. Notice that, as that is a big part of the longitudinal wave. Alright, now let's move on to the next wave. Here we have a transverse wave, in which the energy and the force are perpendicular to each other. However, let's break it down. So here we have the energy and the force which are perpendicular, two troughs, the wavelength between them, the rest, the amplitude, and of course the crest. It's all the same as the transverse wave, except the main difference is that the energy and the force are perpendicular. Up next, we have examples of transmission. Now, let's look at this mentally challenged child try to talk to his table and pretend he has friends. You see the waves passing through the string as he talks to the table, as it is tight. However, now the table talks to him, explaining that he doesn't want to be friends after all. Alright, so let's break it down. So, what is transmission? Transmission is when a wave passes from an object to object, in this case, the mentally challenged child to the table. And here's another quote-unquote friend talking to me on his phone. Here things are a little bit more complicated. His phone sends signals to me through a radio station, and I receive them in forms of waves. Up next, we have examples of absorption. Here we have the beautifully drawn rainbow. Now you might ask me, what's so special about this rainbow? And I'll tell you, it includes all 6 colors, and it absorbs the opposites. So let's say you have red. It absorbs every color but red. Orange absorbs every color but orange. However, what do I mean by absorbs it? Some light waves just bounce back at us. Some stay in the pigment. That's literally the definition of absorption, keeping it in. Back to the mentally challenged child, where this time he tries to talk through a bag. Let's see how he does. Ha ha. Ha ha.
Ivan, really?
Alright, so let's break it down. In this frame, Ivan is talking openly. There's nothing blocking his voice, his sound waves, except for air, and sound has to go through air to actually make a sound. So he's just making normal noises. That's why he sounds perfectly fine. Alright, so let's break down this frame. In this frame, Ivan has a bag over his head, which means that when he speaks, the sound waves he produces will get muffled by the bag, making smaller ones that are harder to hear. Evidently, Ivan's voice is not as loud as it was. And finally, next we have reflection. Again, our mentally challenged child will try to get echo in a very enclosed room that has no potential of getting echo. But let's pretend for a second. Alright, come back there. Good job. Now let's get echo. Sound reflects off the walls and comes right back at him, making it sound as if he just told himself to say echo. Lastly, our mentally challenged friend tries to explain reflection to his friend. Try the same with the mirror. Didn't really work out. Lastly, let's try and explain what happened. So, Ivan sees himself in the mirror. Why does that happen? Because the light waves that fall into our eyes actually represent the image. So if light waves reflect back into our eyes off the mirror, we just see ourselves. Thank you for watching. This has been Ivan Kardashev signing off.